Okay, so that's the print done. So we're just going through a calling process at the moment. So it's just where the fans come into play, over around the centre of the bed. You can just see there, got two calling fans on the underneath. One of them is a 50mm set at a steeper angle, and a 40mm set at more of a leveler angle. And that's all to optimise the calling process. So that's print now has actually been done with a 0.6 nozzle. It's been done at a 0.4 layer height. And the total print time, including the heating up time, so to heat up from 0 or ambient temperature, which was about 18 degrees here on the hot end, and also 18 degrees on the heat bed. Heat bed was set at 80 degrees. And the hot end was set at 210 degrees, as you can see there. So 1 hour 17 minutes to do that build. Now, the good thing is you can see already there's no warping on there whatsoever. Okay, this is a PLA print, so I will be showing you some of the tests that have been done as well with the ABS, and so you'll be amazed at the results that we're getting. There's absolutely no pre-treatment on this aluminium bed whatsoever. You can see there, that's the prime line that was done at the beginning of the print. And if we zoom in there, the quality of the print. So we've got a couple of little bit of missing there on the Z axis coming up on the support, but no deformation or any melting or any hotness as a result of the cooling not being good enough for those. So they haven't deformed or anything from that reason. And what we can do is to test to see if the build plate is tall enough to take the build off without it warping. We just grab the prime line and see how easy that comes off. So that was stuck fairly well still, but we'll give it a little bit of a go now. I'm just going to prise it in the one corner, and there we go. So you can see there, absolutely no treatment whatsoever to that build plate, and we're getting a nice flat build. So again, we pull that off, and I say if it called the heat bed, that's the heat bed at what, 50 degrees centigrade. So if that was down to 30 degrees, that would have just come straight off in my hand. So just goes to show. Now on the heat bed, so we'll just look at some of these features. And what we've done is we've got a mains operated silicone heat pad, and that's basically self-adhesive to the underside of the aluminium plate. Now the aluminium plate acts as an excellent heat sink, so we know that the heat is being evenly distributed. And the good thing as well is because the print table's bed is 400 by 400, which is actually bigger than the volume which it prints, which is 330 we ensures that the edges here also get hot, so as that heat is dissipating, yeah, we're still getting hot around the edges in the areas where it's actually not going to be printed. So that ensures within the build surface itself we're definitely going to have the right temperature in order to stop warping and get good adhesion on the prints themselves. So the wires for that is just plain and simply, it's the two main wires coming down and then passing through to the underneath of the board, where I've got an independent solid state MOSFET, sorry, and I'll show you the wiring on that shortly. I'll turn the machine over. Before we do that, I'll just show you some of the other little features. So the print stream panel now is one complete panel, and that is fastened simply by sandwiching the two. So as the board is in, the 4 screws in the corner, you drill 4 holes into the screen, and then that nicely sandwiches the two together, holding everything into position. And obviously it is, you know, full touch screen, so you can see there. Okay, so one of the other features that we've done, as it says, we've widened up the X carriageway, and we've also altered the orientation of the motor. So before, the motor was coming up and the belt was running centrally, we've now pushed the motor sideways and ran the belt at the back. And the purpose of that was we wanted to get a lower centre of gravity for the actual print, for the hot end and for the nozzle. So what we've got now is the hot end placed nice and central. We've also, obviously with the Titan extruder, we've also put on just the smaller motor. The whole weight of this unit now is coming in about 370 grams. So as a result, we're not throwing around a lot of weight. One of the other things that we've done is we've changed the actual linear bearings. So these are an Indus bearings, they're the European type, and they are slightly bigger than the LM 8UU type bearings. But what I'm finding is the position of these bearings is a lot better, and the smoothness of how it operates. And I'll just move the x-axis 10mm either way, just to show you the smoothness of these. So you can see they're nice and smooth. We've also got them now in the y-axis as well, so I'll just show you on that. So nice smooth action. And also what we've been able to do is, yeah, these are printed in 2 halves. Now before we had the clamps going on for the y-axis bearings, and it was all about trying to remove as many printed parts as possible and making it simpler to build. So what happens now is these are printed in 2 halves. We slot the bearings in, and these little stops stop the bearings from popping out. And then we've got another third one of these bearings in the centre here. So there's actually 3 of these Indus bearings in these, and then it's clamped together, you know, squashing everything together, and then we just run a solder gun all the way around the edge just to bring everything together as one unit. As a result of that, in terms of the belt, yes, we've still got the belt just passing through and just a cable tie clamping it, but then that was the other purpose of having the adjuster for the belt tension now. I'll just show you on there. So we've got a nice adjuster there, and that's on, obviously on both the y-axis and also now on the x-axis, which is just that one there. We've also got the energy chain now, or drag chain, whichever you prefer to call it, coming up, and that's then feeding all of the wires to this. We can still easily swap out the hot end, undoing the front fascia screws. The wires are coming through and we're on a plug, so I'll just take that now. Actually, I'll twist the machine round. So there we have all of the components on plugs. So we've still got the hot end there, which is on a plug unit there, the extruder motor and the cooling fans there. So everything there now is easy to convert. You can see there how the drag chain just slides in between that there. What we've also done is we've fastened the actual belt here onto this fan unit. So by undoing these 2 screws here on this fan unit and undoing the 2 screws holding the fan in place, just try and show you under there. Okay, and what we've done is, as a result, we can now remove all of these items here and just keep that on, and we've still actually got the x-axis still attached. So we remove all these items, and just by leaving this one on, that's still got the belt tensioned up and in position. That's ready if we want to start changing different extruders or swapping out different parts on this, or even start going into the realms of using it as a CNC router or something like that. We can just change the tool head, access these wires here, and have more versatility with the machine. Obviously, with the introduction of the Zed Probe, so I'll just spin the machine around a bit more. Actually, I'll just turn that off. So with the introduction now, with the introduction of the Zed Probe, let's see if I can get that a bit closer over to there, yeah. which is an inductive probe. It also works great with the voltages already provided on the board. So I'll show you how we hook that into place as well. But it also meant that we could do away with the Zed Probe point at the back here, and also in with that we are now able to undo the two ends for the drive rod and uncouple the actual belt, and we're able to just clip this totally out of place and back into place without having to undo any of the supports anymore or anything like that to get that in and out of place. We've moved the Y-axis end stop to the rear there, and that's again, that's just to aid with the wiring, having a shorter distance and having it all at the front and running down from the back as well. We have had to beef up this energy chain here, so we've had to go with a bit of diameter on the energy chain. That's a 10mm by 15mm diameter one, and that's because of the amount of wires now which are running up through here. And in also doing the wiring, by doing away with the spin the machine round. Okay, so what we've done now as well is we've printed off these, just basically cable tray, just for all the cables to run up. So that's the main harness there, and that's running up inside and then running inside there and back out to feed the motors. These are printed in 4 individual units, and then they're just basically soldered together just to form one nice neat unit. And obviously it's nice and easy to just get the wires, clip them in and out. In with the filament feeding through, so at the moment we're just feeding the filament up through this hole here, and I'm just letting it run freely into the extruder. I'm finding that I'm not having any jams. I was going to try it with putting just a sleeve on just to make it any smoother or this and that, but I'd say at the moment I'm not experiencing any problems with any jamming or anything like that, so I don't think there's any need to address that at this moment in time. These trim covers here, they were never ever included in the instructables, but we are going to have these loaded on to the website now, and they are just literally just trim covers that we just print off. It's all in the nice same colour, and that's just to close off the cut edge that we do and be able to obviously access the wiring through. We have made these slightly shorter, and that's just to get slightly more drop on this because of us lowering the center of the extruder. I didn't want to lose any of the Z height. The Z height is currently running at just under 300 millimeters, so I don't really want to publish 300 millimeters under this build, but I am currently working on this unit, which I'll show you there. So this is going to be the unit that we're going to be slotting in. That just sort of like keeps the center of gravity, but brings the extruder height back up again, and then we should be back to being able to safely publish 300 millimeters as a Z build height. I mean, this is with the Titan extruder, it's not the Titan, sorry, the Volcano hot end installed. That's where we tend to lose the 5 and 10 mil of the build height. So in order to make sure with the Volcano installed we can have a 300 build height, that's why I'm just quickly modifying that. And I was finding I was having just a little bit of flex in this, not much. You can just see the rock there, but I'd say this new one that I've done here, that will totally remove that as well. So that will make that a lot tighter, and let's say release me back my Z height as well. So the one that you've seen on the machine here won't be published. It'll be this one here which will be published, which is going to be fitted as part of this video tutorial, which I'm going to be doing anyway, in stripping this down and showing people just how easy it is to build. Obviously the feature there with the cam lots, you can see all of the cam lots in place. What that essentially means, just come round on that view there. So what that essentially means is we can just simply turn those, and this entire head unit here can be lifted off, especially with the two plug wires here. So a plug wire there and a plug wire there. We have to undo the mains from the board. So undo those, unclip those from the board, but we can actually take the entire head off and work on this entire piece. We just have to ensure that we drop the bed down, because we lose the support from these two tops when we take the top off. What we've also done, and we're going to include, is the STL print for the Zed rod nut. So we have now decided, and the change that we're going to be taking forward, and the recommendation for the print table is actually an 8mm Z rod with an 8mm pitch. And what you get as well is you get the little brass nut. You can see there, and that's how that's all nicely faceted and screwed in nicely. But what we're finding is we're getting a lot more of a smoother action with this. So it does move a hell of a lot more smoother, a lot more quicker as well, because obviously the pitch is 8mm, but it's not impacting anything on the actual resolution of the Z height anyway, on what we're printing. So we can still come through print at 0.1mm if required, but you know, my thought is unless you're going to start putting in a 0.2 nozzle and start printing something really small on the print table, yeah, you can do it. It has not a problem in doing that sort of a print. But the question is if you've got such a big build volume, would you want to be printing small items so much? Now, that says there's no wires now passing through the legs themselves. So it did pose a bit of a problem for the screen wire, but because it was just a ribbon, we decided just to put a nice piece of a thin double-sided tape down, stick it to the inside of the leg, then just pass it through the table underneath, and then put this nice little trim on there just to cover it up. Obviously we need to cut a bit of hole underneath here for the plug itself to be able to pass through, and so that trim there just covers that up nicely. Okay, so everything on the Z motor and the way the Z motor all mounts is still all exactly the same. These are, it's just a little print that I've done as a collet, as a spacer, because I'd ordered a load of 10mm couplers, but now switching to the 8mm meant it was oversized. So I just quickly printed off this little coupler here that clips in, and that just helps to reduce the size down. The bearings inside there are still the steel ball bearings, so they're still the 12mm rod, so LM12 you use as the bearings, and that's obviously because of the linear action that we're running on here. It wouldn't be wise to put any of the dry English steel dry link type bearings on that. I have tried it, couldn't get them to work successfully. The roller bearing option is always going to be the best option for the vertical axes. So I'm just going to quickly try and flip the machine over, see if I can do this while I'm holding the camera as well. So the machine is still extremely light. Okay, so we will be designing a nice bit of casing for the electronics board, just start getting all the wires out of the way and start making it, all of that, a lot more safer, and so no one can get their hands on it and start touching any of the wiring on it. We've installed a plug socket on here with the on and off switch, so we just use a kettle type lead to power up the print table, using still the 12.5 amp power supply. Now we're running on the UK voltage, we're running a 13 amp fuse in the plug. We're then switching that down to a 10 amp fuse in there, and obviously the power supply can draw 12.5 amps. So the whole idea is by putting the 10 amp fuse in here, if we have got any problems or anything like that, we would hope to see that fuse will blow fairly quickly. This is what is controlling that mains heat bed. So we've got the one wire which is attached to the live side So it's just basically just piggybacking off the live feed going into the power supply. So this is the mains lead going into the power supply, and that's running into the MOSFET and then into the wiring, then going up to the actual heat bed itself, and then the other wire is just to the negative side of the AC connection. And so that controls the switching of when it gets power, when it doesn't get power. And that is controlled. Simply what we've done is we needed a 12-volt supply, so we piggybacked off one of the end stops just to grab the sorry, it only needed a 5-volt supply, sorry. So we piggybacked off one of the end stops, and even saying at 5 volts, this is set to 3.5 volts, and it's still, everything still powers up fine. And so that's just the power into the MOSFET, and then the signal wire is the green wire. So I'll just show you on there. So the signal wire is the green wire, and all we've done there is tapped into one of the GPO pins down here, and then told it in the config file that is the controller for the heat bed itself. What we've got then coming out through the wire down here as well, which should be this one here, is this black wire, and that's coming up to here, which is the straightforward thermistor. So that's measuring the temperature of the heat bed, and obviously the controller then is telling when to switch on and switch off the heat bed once it gets up to temperature. So fairly straightforward on that. The Zed Probe obviously still goes into the Z Min end stop, which is these 3 wires here. I've coded them just slightly differently because the wires are a different colour on the end stop anyway. Traditionally I like to use yellow, white and orange for end stops, but that also just helps me to identify that that is the Zed Probe, and obviously to treat it a little bit differently. Okay, so nothing really changed there on the wiring, obviously just this added feature. And in the UK we're buying these, I think that one cost me £12.99, so it's around about £13, which in today's currency would probably translate to about probably about $15–16 US dollars. So you know, something that you can consider. I know there is other options out there with the solid state relays and this, that and the other, so it's just an example of the way in which I've done it. And the way I did this particular circuit in particular, I liked it because the AC up is totally independent. So it doesn't matter what goes on with the board, or what goes on with this board, or what goes on with the AC supply. That AC supply can never ever interfere or reach feedback through onto the board itself. So I'm never going to worry about blowing the board up. Okay, so just printed off these little legs. Yeah, so this is a desktop version. As a result of that, if you're going for the desktop version with the 2 little legs, there's no need to actually cut down the big long screw that the lat table screws come with, that we would have to cut down because the 2 legs would meet and they would interfere with each other. So if you know that you're going for a desktop version, absolutely no need to cut down the screw. It just screws straight in. But like I say, I'll be showing you this on another video.